Hello everyone, the topic we have chosen for this presentation is beef. No, you're not in the kitchen. Yes, you are in the attack and defense presentation session. And let me welcome you to Group 7's presentation, where the topic is about browser exploitation framework, which in short is called beef. This is Akifa, and me along with my teammate Shiva will be showing you how we did the exploitation with beef. Before that, let me give you an overview of the presentation. So here, after I'm done with the introduction, I will be talking about the features and history, like the background history, and how can you install beef, how does it work, the impacts of beef, the usage of beef in real world, and then I will be talking about the project we have done, technical components we used, and the reason for choosing this topic. After that, Shiva will show you the demonstration of the project. So let's begin. With the general computer users' understanding of information security raising, at least to the point of not clicking on unknown links, and operating system security getting better by default, we need to look for new and creative ways to gain a foothold in the system. Luckily, there are tools available for us. Beef is one of them. As I mentioned earlier, BEEF stands for Browser Exploitation Framework. The objective of this framework is to launch a client-side attack or hook victim's browser. BEEF framework is the only tool which is exclusively used to exploit web browsers. Regarding the features, there are lots of features available in this framework, like the extension API, RESTful API, browser proxying, integration with Metasploit, PhoneGap modules, plugin detection. Also, this is an open source framework. Well, regarding the background, this tool was developed by a group of developers led by Wade Alcorn. Built on the familiar Ruby on Rails platform, BEEF was designed to explore the vulnerabilities in browsers and test them. In particular, BEEF is an excellent platform for testing a browser's vulnerability to cross-site scripting and other injection attacks. BEEF can generate a link that can track the target and even run modules to both escalate permissions and gather more information about the person behind the computer. Okay, so why browsers? The reason why browsers are used as a medium of hack the PC is because people use browsers for all types of things, and in general we trust a lot of personal information with them. That's why browsers are the perfect attack surface for a hacker, because the target may not even know that they are infected and fed you with all the information you could want. Okay, now that we have some knowledge about BEEF, let's see how to install it. The installation process is pretty simple. Before installing it, you need to install Kali Linux in your machine, and then you can simply run this command. After that, you can just run this command sudo beef xss the way I did it. When you're doing it for the first time, they'll ask for a password. After you set that, and after the successful execution of this command, this web page will be automatically opened. Okay, so after you are done with the username and password, the credentials you have given, you will see this web page. And here in online browsers, under this section, you will be able to see the IP addresses of the victim PC or the PC you have hooked. So just like this. This is one of the screenshots from our project. Okay, then how does it work? BEEF is, this framework is similar to Metasploit. We all know Metasploit, right? Because we have done our assignments and exams with this. Anyways, so BEEF uses a JavaScript file that's called hook.js, which when executed by a browser gives a hook to BEEF. With the hooked browser, similar to Metasploit, you have an array of exploits in front of you. Some of them are viewing cookies, browser history, to the more sophisticated attacks of getting a shell. So how does it work to make to make it more understandable? We have created a small chart that is kind of an example like what you can do with Beef. You can just create a malicious link and send this link to the user. So when the user clicks on the link, the attacker will see the Beef control panel, which means Beef server communicates with the hooked browser through a web-based user interface and thereafter launch the exploit. The Beef launches a Beef instance, which is combination of the UI server, the UI which is used to launch attacks and shows the various exploits, and the communication server which coordinates and communicates with the hooked browsers. These two servers in collaboration makes Beef work. We have already got an idea what the impacts it can have to the users, because if the user clicks on any malicious link, the attacker will in result get the sophisticated information of the victim PC and can launch attack. Sophisticated information includes ID, password, or even the attacker may be able to access users' webcam as well. These are quite risky, right? Alright, now that we know that what is Beef, how to install it, and what can be done with this, let's discuss if Beef is used in real life for any purpose. Yes, it is used as a serious pen test tool and famous among the penetration testers. Penetration testing is, by the way, also known as ethical hacking, is an authorized simulated cyber attack on a computer system performed to evaluate the security of the system. In most cases, when you demonstrate an access to a client, assuming you are a pen tester, it does not have that much of an impact when you show them a silly pop-up. On the other hand, if you demonstrate XSS using Beef, now that will give them a scare, and hopefully they'll be conscious from the next time. Beef is unique among pen testing frameworks because it does not try to tackle the more secure network interface aspects of a system. Instead, Beef clings on to one or more web browsers to use as a pavilion for injecting payloads, executing exploit modules, and testing a system for vulnerabilities by sticking to browser-influenced utilities. Now let's come to our project. There are lots of various things you can do with Beef. However, we have done 3 so far. The first one is getting a reversed shell. We, with the help of Metasploit, we did this. And the second one is Google phishing. Google phishing is just like the one I showed you previously with the chart. You can create a link and give this link to the user. After clicking on the link, the user will get a web page just like this, which looks like Google's login web page. And if they try to log in, they won't be able to log in. But if they give the credentials and click sign in, the attacker PC, means we will get the credentials, the username as well as the password. And with Pretty Theft, you can do it in for Facebook, for YouTube, and LinkedIn as well. We did it for LinkedIn. Okay, the technical components we have used is of course Kali Linux and Beef and Metasploitable 3. We needed an attacker PC, which is actually the Kali Linux, and the victim PC. For the victim PC, we used Windows. The reason behind choosing this topic was our interest in hacking and cybersecurity, because to protect a system, we need to know the loopholes or how to crack it. Secondly, Beef has apparently very clean interface by organizing attacks based on type and also indicating if particular attack is relevant to a browser. So you can just point and click on the attacks to launch, which is why it is a pretty good tool to start with as a beginner. Alright, this is all from my end. Now my teammate will show you the demonstration of the project. Thank you.
Thank you, Akifa. Now we'll look into how the attack is performed. First, the attacker sends a HTML page with hook script to hook the victim to the Beef UI. Once the victim opens the link in the browser, it automatically hooks to the attacker's Beef UI without any further steps from the victim. After a successful hook, the attacker now can execute the commands from Beef UI to get user credentials, redirect the victim to different pages by maintaining a persistent access, and we can also use different payloads as plugin updates and ask the victim to install to gain a Meterpreter shell where we can perform more attacks. Here is the malicious HTML file to hook the target browser to Beef. So the malicious HTML code has the JavaScript file for hooking the victim browser to attacker Beef UI. So this HTML just shows a embedded video along with a malicious script which is taken from the attacker machine. Performing an attack using Google phishing page. Now we will look into how the victim is prompted with a Gmail login page where he needs to enter a username and a password and click sign in. So now for instance we'll refresh the page so that attacker sends the code. So after a successful hook on the hooked online browser section, we can see the victim browser here, and here by navigating to social engineering module in commands we can see Google phishing command. So we will select that and we'll give a XSS hook URL as https gmail.com so that when the user clicks on the sign in, then he'll be prompted with a Gmail login page. So here the user will be prompted with a Gmail login page. So he'll give a username as attack and defense at mits.ca and password as I am hacked. So once he clicks on sign in, he'll be redirected to the Gmail about page, and can see that the about page, and after going to the attacker machine we can see the result as username attack and defense at mits.ca and password as I am hacked. So here we can get the user credentials. Getting victims credentials using PrettyTheft. Similar to Google phishing, we now use PrettyTheft where we can prompt user for different social network sites to log in like Facebook, YouTube and LinkedIn. Here I'm selecting LinkedIn and I'll go back to victim browser and I'll show that there is no pop-up and can play and pause the video. Now we'll prompt the victim with a LinkedIn login page to steal the credentials. So I have selected LinkedIn and I have clicked on execute, and when we go back to victim's browser, here it is popped up with LinkedIn login page. So here I enter email as mits at attackanddefense.ca and I have given password as OTU, and when I click on sign in, it just signed in. It did not prompt anything, so that user will not be aware of that. And when I go back to that Beef UI and I see the answer as mits at attackanddefense.ca and password as OTU. Now we'll look into the persistence attack. Here in this demo I'll show how to get a persistent access to victim browser by creating a pop-up window at bottom left corner. So we'll navigate to persistence in command section and then to create pop-up under, and then we'll hit execute. As you can see here, the URL is pointing to the attacker server to maintain persistent access. Now we'll see how to get a reverse shell by installing a payload plugin. So after a successful persistence attack, we now use a fake notification bar for Chrome. So that is under social engineering tab, and here what it does is it gives a notification pop-up to install the plugins. So here we'll give a notification text, then we'll give the payload in the URL section, where the payload will be created using MSF Venom. So here I'm giving the payload as payload URL, so it's http 192.168.245 and 133 on port 3000, and it is stored in demos, and it will be named as update.exe. So once we open the console as root user, and we'll run the command msf venom for Windows Meterpreter reverse TCP by giving the attacker address as lhost and the attacker lport, and we'll output the file as update.exe. As it will be running, it will be creating the file. We'll open up msf console and we'll use exploit multi handler, where we'll be setting the payload as Windows Meterpreter reverse TCP, and we'll be setting the lhost as 192.168.245.133, and we'll also set the L port as 1337 as we previously gave in for the payload, also the same. So here we'll run the MSF from the MSF console, and we'll start listening for the Meterpreter shell. So we'll now go to Beef UI and we'll give the payload and payload location, and we'll click on execute. Then once we go to the victim machine, so it says to continue watching the video please install the plugin. So once we click on install missing plugins, it will download a file. So once the file is open, we click on yes and we run it. So once it is run, we'll go back to the attacker machine and we'll open the MSF console terminal, so where we'll be having a Meterpreter shell open, and we'll type sysinfo to view the system information OS build. So we have the computer name as desktop -98, so we'll verify the same with by going to File Explorer and right click on this PC and properties. Then we'll verify the computer name. So it is same as you can see here. And once we go back to attacker machine, we'll also check for the Windows build. So here we'll check the Windows build. So on the victim PC, once we go and we'll press Windows R to view the run terminal, and when we click WinVer, so we'll get a pop-up about the Windows, and we'll check for the Windows build. And so this is basically done for planning further attacks. And now we'll navigate to C drive and we'll list for the files that are there, and now we'll verify if the files are same or not. Once we go back to the victim machine, so we'll open the File Explorer and check if the files are identical from the terminal machine, from the attacker terminal machine. So all the files seem to be same, but some files are like hidden, and we'll make a directory named you have been owned. So where we are creating a file, and once it is done, we'll verify the same in the victim machine also. So here it says created directory, and we'll go back to victim PC file explorer, and it says the folder has been successfully created. So we'll navigate to the directory as you have been owned. So now we will look into what are the mitigation steps. These are some of the mitigation steps that can be used to avoid the above attacks. These are the references for the images used in this presentation. These are the references we use for demonstrating the 4 attacks. Thank you. We are ready to take your questions and suggestions.